So hi everybody and welcome back to C++ tutorials for absolute beginners. This is video 353 and in this video we continue with our move assignment examples. And again, here in language section you go to move constructor, and here down we stopped anywhere here. And again I used here the compiler explorer, and then we go on from our last video. But in this case we have now two options, this one and this one. Then the compiler will prefer the R value reference here, which means it will use the move semantics, and this will call here the function body. And this one is performing an assignment. And how? First of all, it starts with the right hand side, which is it takes other. Other is this variable name, and careful, a variable name means all time it is an L value because it is a named variable. Even we have here the type R ampersand, which indicates an R value reference, but then we take from it the variable, the member S, which we want try to assign to this S here in this new object. Because this is a named variable, an L value, we convert this again here to with std move to an R value, so we can use again move semantics, because S again is a string. A string can have constructors, move assignment operators, and all this kind of stuff. And with this one we let the other object, this here, in a valid state, because this is move semantics again. Here we just print out the move assignment. If it's called, we check this here on the right side, and we can see the move assignment is indeed called. That was the step from here to here. So indeed the move assignment is called. And when we jump back here to line 26, then we return here just the word this with an asterisk. Let's talk fast about this word this here again. In short, the word this itself without this asterisk is just a pointer, and this word this is pointing to the struct A location, so the address of the A. And when we use now this asterisk here with the this, so we are differencing a pointer, which means I want not the address of the pointer, I want the object, and the object is A because we are pointing to this address of A, and the object itself is A. And when we are returning now A itself here to this place, we have every option available again. And this is interesting because we can use with that chaining. So let's make a chaining example, but before that let's finish our assignment. So we jump back to our call, which is line 58. So we assign this part to A1. A1 has now the new value which we created here from this temporary object. That was this S. What was created with S? That was test. Test was set here, assigned to A1, and this temporary object was let in a valid state. But in this case this valid state makes not much sense because the whole object is temporary, which means after this semicolon here this part will be gone anyway, but A1 stays because this is a named variable, a variable we can use later, and we can see this here. Now let's make a chaining example. We jump again back here to our assignment operator. Here was this, and I told you this here is referencing the object here again. So we have the object back when we use the assignment operator. With that we jump again back to our function here. And with this chaining effect, I can do something which looks a little bit strange. Let's create first two new objects. I make just here on top A3, A4, and then I go down here, and this chaining effect means this operator, let's jump fast on top. This is an assignment operator, right? And the assignment operator says, I give you back this object. I go down, and now I can, after I have finished this one here, I can write again assignment operator, and I say A3, and after this one I can assign again because this one is also returning an assignment, and A4. Let's make here A4 too. But this will only work if the assignment operator is called. So if the assignment operator here from this part to this part is not called, this will not work, because you can see the assignment operator has this return reference, but the constructor, if the constructor is called, with a constructor you can't use chaining. There is no return value as a reference. So you can see the chaining here is working. We have here no compiler error. This is the first nice thing. Yes, it is working indeed. But this one looks very strange. We have here assignment, and here assignment. When you see something like that, remember there's probably a reference which uses chaining. Also interesting is this chaining here is not using the move assignment operator, which I have showed you here. Instead, it is using the copy assignment operator. So let's go here to the line 58 and try to figure out why this happens. First of all, the compiler will build here groups when it is chaining. First, it will build here a group, this one here. So let's make here this group is the first group. And after it had finished this assignment here, then the compiler will make another group, which is this group with this group here. And after this is finished, after this is finished, the compiler will make another group, which is the whole part here with this. Of course, this kind of stuff you have to know, because you will all time see just the chaining without this grouping, what the compiler is doing. Okay, let's start here with the first group, which is this one here. And we have here two L values because A4 and A3 is already created. And we're trying to assign A4 to A3. And this one will call the copy assignment operator, because this one is an L value and an L value can't bind to the move assignment operator, so it has to be called here. And we can see this also here on the side, the copy assignment operator is called. Then this group here will be assigned to this one here. We have to first create this temporary object here, and we can see that the temporary object is first created here on the outside. So the constructor is called and a move constructor called, which we have talked before. After that, we assign this part, which becomes an L value, and that is very important to notice here, because this combination of that one becomes an L value. And the reason for that is all time this return value of this assignment operators. And interesting is also both are returning an L value reference, which means all time when we combine something, it will be an L value reference. And an L value reference means if I try now to assign this part, which is an L value reference, to this part which we just created, again the copy assignment operator is called, and we can see this here. Careful here, now we have assigned this part to a temporary value, which is all, which makes now all this part here we are assigning to this one with a temporary value, but it is a L value reference. Even this one is a temporary object here. Again, why? Because the return value of an assignment operator, doesn't matter which one, is all time an L value reference. Which means, in other words, in our case, even we have here a temporary object now, which we are trying to assign to A1, the copy constructor must be called, because L value reference can't bind to an R value reference here. And again, we can see this one in the output. Copy assignment operator is called. That was our last step. Okay, and with that, I think we stop here the video. Try to repeat this a little bit. It's a little bit complicated, but not too much, I hope. And with that said, if you have any questions, like all time, write in the comment section. See you in the next video. Bye and good luck.